I finished my steering. As you can see, I'm using a rack and pinion unit. It's from Mustang 2, and this is a favorite of hot rodders, so they're very available out there, and they're pretty inexpensive. This is a manual rack, a non-performance rack, in that it takes more turns. There's 4 turns lock to lock on it, which is what you want. It's also the least expensive at about $75, including shipping and tax. But there are some things you need to do to modify it to fit this application, particularly since I'm using Raptor spindles. So I'll take you through some of that. So one of the first things we had to do was look out here at the spindle here. Now this ball joint originally came out at 90 degrees, but with the angle we've got here, and this is the proper angle through my C-Spus suspension modeling tool, I had to break it here and weld it on at an angle so it would be in a straight line, and my ball joint would be able to articulate its full amount here. Okay. Then the next thing is of course this is the Mustang 2 rack, and the rods that were on the end of this were huge and wouldn't fit with the threads that came on the Raptor. So I cut off the rod right there, and then took the inside ball joint from the Raptor. There happened to be 2 ball joints, one on the spindle and then one on the steering mechanism. So I cut off the ball and used the threads because, of course, to make this work properly, you need a right-hand thread and a left-hand thread. So all you do is loosen these 2 nuts, spin it, and you can tighten or loosen without taking everything apart to do your adjustments for your toe. Okay, so welded that in. Then these were way too long. They were about 4 times as long as this, so I had to cut it down and then tap out. I kept the side with the left-hand threads and tapped out then cut the other side and then did a right-hand tap, because it's easier to find a right-hand tap for a metric thread. And by the way, that's an M12 with a 125 thread pitch. Okay, so we did that and got it all connected. Then the next challenge was that the Mustang rack moved back and forth far too much for the size of the spindles, and that's basically how far the ball joint is from the kingpin, which is much smaller than it is in a Mustang 2. So I had to make some stops to ensure it wouldn't steer too far off to the right or to the left and hit the body. And the convention for how far a steering rack should turn for a street car is 30 degrees. So what I did is I came in, tore off the boots, as you'll see here. Took the boots off, came in here and figured out how far I did want the steering rack to move back and forth to give me that proper 30 degrees, and then came up with this. I welded in this stop here. You can see right here. I'll turn the steering wheel. Figured out where it was, and there's an internal flange in here. It's a solid piece of casting, and this is just big enough to go in and hit that casting. So that gives you a very solid stop, gives you 30 degrees on one side, and I did another one on the other side. And it gives you a very solid stop. Now you do need to weld that in. You don't have to do a full weld, but you want enough so that thing doesn't fall off in there. Now since this thing is pushed up against this edge of this flange, it's not really taking a lot of force because it's just up against the flange, but you do want some welds in here. Just to keep it from falling out and make sure it's solid, because you don't want this thing falling out in the rack, because that could cause your steering rack to stop working, get caught up in there. So that's good and solid, it's more than enough to be solid, but I've got steering that works. I worked it out so that top bar is pretty much exactly where it's supposed to be in terms of height for the rack. The rack height is very important to ensure you don't get bump steer, along with ensuring that the joints in here are in exactly the right place. And this is about where they are, and it's more or less in line between the bottom pivot point and the top pivot point, and the joint is right there. So it's in exactly the right place, exactly the right height, all coming together. Got it mounted in a lightweight fashion. So you don't need as much attachment as you do as far as bolts goes, size of bolts to attach the rack. So what I've done here is I've gone from a huge 5/8 bolt down to a 3/8, which is still plenty, but I did go with hardened bolts just to make sure. And then I bought aluminum sleeving to fill in the space between the 3/8 and 5/8. So it's a 3/8 inside diameter, 5/8 outside diameter. Slip in there to ensure everything still stays very, very tight. But that's plenty strong. Now, when locating those bolts, you might assume that these mounting bolts are centered. They're actually 16 inches apart, and you would think it would be centered on the rack. But that's not the case. Ford does have a way of doing some funny things. This flange to this bolt is different than this bolt to this flange. It's much closer on this side, so if you mount that thing centered as I did here, your rack will actually be off center. Now that's kind of what I wanted to do here anyway, because it's pointing away from the driver. I'd much rather have that thing pointing towards the driver. Try to find a rack that did do that. I couldn't find one, so I ended up with this one, but I think I can make it work. But consequently, you want to move this over as much as you can so you don't have to you're not as far over and trying to bring over the shafts or the universals. So I did mount it offset to this side to bring it over as close as I could. So one of the things you'll notice on this side is I got about as close as I could, and when you look at the stop compared to the other side, you'll see that this one is much, much smaller. With the stops welded in, I'm at about 2.5 turns, which is good. That's kind of a sporty feel. I'm kind of right about where I need to be. So that's why you want to get that low performance with a 4 lock-to-lock turns, is that gives you room to put the stops in and still have some steering left. So here's the completed front subframe with the A-arms, the cantilever suspension, and as you can see here, the steering is on there as well. You can also see that I've now removed the jigs I had on either end that held up the spindles at the nominal position. Once I put the wheels and tires on, I did a quick alignment, but found that it was in near perfect alignment with no adjustment to be made. And that was with all my adjustments in the center of their travel. So I'm feeling pretty good about that and ready to move on to the next step.